All right. Let's get started. Thanks everybody for coming. We're super excited today. We're going to be sharing some really excellent material. So I don't know if this will be a series or not, but we have today a treat because we're going to be visiting with some Codefresh users, some power users from Tigris Data. We have their CEO and co-founder, Ovais Tariq, as well as their founding engineer, Robert Barabas. They'll be sharing how Tigris Data uses a GitOps approach to do infrastructure management. Of course, my name is Dan Garfield. I'm the co-founder and chief open source officer here at Codefresh, and I'll be on board to facilitate some Q&A. Throughout the session, you're going to be learning about how you can use Codefresh to manage deployments at scale, growing numbers of environments, and of course, maintaining multiple ArgoCD instances and saving costs along the way. So be sure to stick around till the end because we will have some free codes for our GitOps certification. If you haven't done that before, it is the most popular, fastest growing GitOps certification on the planet. I think we're up over 19,000 students now. And of course, 100% off is a huge discount. So stick around because you can get that free code at the end and you can be just like Ovais and Robert, who are going to be crushing it in today's session. One last note before we kick this off. If you have any questions at all throughout this session, drop it in the chat, add it to the Q&A. We'll be sure to get to it. So Ovais, Robert, are you ready to get started?
Yeah.
Sure.
Very excited to be here.
I pass it off to you then.
Yeah, thanks, Dan. Thanks for having us here. Let me share my screen really quick and the slides. So as Dan alluded to it, we are going to be talking about a GitOps approach to infrastructure management, which we believe in here at Tigris Data. And I will let Ovais kind of talk a little bit about the company in a second. But at a high level, what we'll be covering today, we'll talk a little bit about us, our use case, our challenges that we're expecting to solve. And I'll explain a little bit about why Tigris chose Kubernetes first. What does that mean, Kubernetes first, here at Tigris Data? And then we'll be diving into managing ArgoCD at scale. You'll hear a little bit about some of these considerations we had and some of the challenges that we anticipated. How did we tackle that? How did we look at that both from the aspect of technology and management? And we'll be talking about a very specific subject after that. That's a relatively recent feature. It's about 6 months old. Benefits of using tunnels with ArgoCD. And then we'll talk a little bit about somewhat debated subject on how you should provision your infrastructure. What are the benefits of using ArgoCD for infrastructure provisioning versus Terraform? And then we'll do a conclusion, and there's going to be a Q&A that will crown this session, if you will. So with that said, I'll let Ovais talk a little bit about us and the company.
Thanks, Robert. It's a pleasure to be here. So let me briefly talk about myself, and then Robert, you can talk about yourself. So I'm co-founder and CEO at Tigris. We have been building Tigris for the last year and a half. Prior to that, I was leading storage infrastructure at Uber. Storage infrastructure organization essentially responsible for providing all of the core database and stateful systems at Uber. And even at that time, that's about 6-7 years ago, all of those stateful workloads were containerized. So I have a long history with running containerized workloads. Robert?
Thanks. Yeah, I have similarly been around data a bunch, and most of those jobs that you see there either revolve around me being a consultant or building some sort of database as a service on legacy platforms, and later on top of Kubernetes. And I was very happy when Ovais reached out to talk a little bit about his mission with Tigris Data and the way he explained, he wanted to tackle this specific issue and how he could, get us the results that we seek. if you have any questions about any of the past jobs of mine, feel free to hit me up on LinkedIn. I'll be happy to talk to you about it.
Great.
All right.
So yeah, let me talk briefly about Tigris. What is Tigris? Tigris is a storage platform for real-time applications that makes it easy to store and access any volume of data. So think of Tigris as a massively scalable global KV store that allows you to read and write data from anywhere in the world, and allows you to store arbitrarily sized values, whether these are small values, less than a kilobyte, or large values, a couple of terabytes. Any kind of use case related to storing and accessing data. That's what we are building at Tigris, and we are specifically focused on cloud native applications as well as mobile apps. Next slide. Yep. Let me talk briefly about why Tigris chose Kubernetes first. So when we were building Tigris, our goal with building the platform was to make it available to our users in all of the cloud providers, as well as on-prem in a data center, if a user chooses to use that. So what we were looking for is some kind of a common denominator or a common way of managing resources and workloads. And the best system to do that, of course, is Kubernetes. Kubernetes has been around for quite some time now and has seen vast amount of adoption across the board. And Kubernetes is the platform that is available in all of the major cloud providers and is also something that people are used to running in their own data centers. So Kubernetes essentially provides us with that common layer that enables us to focus on our workload instead of focusing on building bespoke systems that each have to be run differently in each of the different cloud providers. That was the primary reason we chose Kubernetes. Other reasons for choosing Kubernetes were related to how we were thinking of designing the system. Robert, if you would go to the next slide. So we wanted to design the system in a way where it's disaggregated in architecture. And what I mean by that is each of the major components need to be separated out so that each of them can be operated individually, upgraded individually, scaled individually. And you can see this high-level architecture diagram here on this slide, which essentially talks about some of the resources listed here, like the query engine, the foundation DB clusters, the indexing of the data, auth and other services. All of these functions, we wanted them to be independent from each other so that an issue in one doesn't affect the rest of them. And also because, as we are talking about, as I mentioned earlier, that it's a large-scale KV store that supports different type of different size of values and different type of data access pattern. So that does mean that to support all of these different types of workloads, we need to be able to scale individual components separately. Some of them would be compute-heavy workloads. Of course, they require the query engine or the compute engine to be scaled. And the other workloads which are more, storage heavy, they would require, the storage component, which in this case, foundation DB, to be scaled independently. And of course, from a deployment perspective, as I was mentioning earlier, we wanted to have the flexibility in terms of deployment. So whether it is deployed in Tigris's account, whether the data is hosted in Tigris's VPC, or whether Tigris is hosted in a customer's VPC or even in a customer's data center, we wanted that common orchestration layer that enables us to manage all of that by using the same tooling and by having a small team, not having to grow the team for each of these individual deployments. Next slide, please. And of course, as we talk about having this disaggregate architecture, this essentially comes down to having a microservice-oriented architecture. And this is just an example of some of the microservices that are available within a deployment or that have to be deployed as we create a Tigris deployment. And again, by having these microservices manage all of the critical functionality separately, it makes it easy for us to roll out new version upgrades for individual components. Suppose that we have a new auth feature. Now you don't need to take down everything to roll out the auth feature. You can just take down the auth microservice, and even there we can do it in a phased way. And again, if for some reason some specific part of the deployment needs to be scaled, again, this type of microservice oriented or disaggregated architecture allows us to do that in a simplified way. Next slide. So from here on, I'd like Robert talk about actually operationalizing this type of microservice architecture at scale. And Robert is going to talk about some of the challenges related to scale and how we resolved it.
Thanks, Ovais. It's been a lot of fun operating this environment, I have to say, just because it's modern, it is easy to extend it with the different pieces. And it's been, really, really nice to have all the features that we have built available to both of our developers and the SREs. If you can call us SREs, but what is the growth that we are looking at here? What's the challenge? So you obviously have a plethora of different cloud providers that you possibly need to support a large variety of infrastructure. And then since we started early last year, we have actually grown quite a bit. Our number of applications have skyrocketed. And along with that, our capacity requirements and regions and continents have as well, as we adapted to the needs of our business. And all of that, we still managed to keep the team relatively the same as it was. And we are still roughly 10 engineers, with most of the engineers working on the deployments and only a subset of us being more focused on the infrastructure. So how did we do that? What were those growing pains that we have experienced? Well, at the start we had, like most of you probably do, growing number of standalone ArgoCD instances. We initially just deployed ArgoCD, found it to be very easy and intuitive to use. And when we provisioned our clusters with Terraform, the Kubernetes clusters, then we used an external Helm chart external to the ArgoCD project to bring the ArgoCD instances up in said cluster. But what we have found was that through the months as they elapsed, and we had other priorities to develop the platform of Tigris and the different features to the database. These upgrades kind of got deprioritized. And as these instances grew in numbers, we didn't have SSO, so it started to become a little bit cumbersome to ensure that our logins are in sync, and we have set this up, and it started taking a little bit of a toll on the team. And mind, we are a very small organization. So we wanted to tackle that, head on. And then some of these problems probably are common across the industry. Some of these are goals that, for example, the reasonably mitigating risks and extent of incident that's probably shared with other businesses. I'm expecting that keeping up with the reliability updates, the bug fixes and the security patches for your ArgoCD instances is also a very generic goal. But what was specific a little bit to Tigris was to allow us to delay building a dedicated team, what seems to be a relatively challenging economic landscape, as well as the ability to deploy these ArgoCD instances on-prem for our customers and be able to manage that. So those two seem a little bit contradictory. Not building a dedicated team and still be able to offer this to our customers. And we had to tackle that head on. So we looked at the two major paths, if you will. The first, what if we had a few large clusters, a few large deployments of ArgoCD, or what if we had a lot of smaller deployments, many smaller instances of ArgoCD? What would be the pros and cons? And this is essentially what it boiled down to. With the larger deployments, we got the SSO part out of the way, so to say. We could get that overview. It was still not a holistic, unified dashboard, but we could get that overview, and we would have to, do these updates with fewer times. But these updates, unfortunately, would have a lot bigger blast radius. They would become more complex as we have essentially a lot more customers on it, a lot more applications on it. So you have all that complexity that may come with managing the different resources in it. And we really therefore like the idea of trying to do smaller deployments instead. However, despite the benefits of it, that it would simplify the maintenance, you would probably feel less anxious about doing these upgrades on a smaller instance, and you could do it in a more granular fashion with mitigating the risk and the impact on the customers if something goes awry by any chance. We felt like this would contradict the goal of having to build another team. It would come with maintenance overhead. You would have to write some sort of pipeline or automation to do these updates. It would be hard to oversee the individual instances and get holistic numbers on how your deployment perform. And we would have to more heavily probably invest into our custom automation for said pipelines and maybe more to operate these environments. Again, mind that we are a stateful workload, so in a way we have to apply some finesse to these updates as well. So in the end, we chose many small deployments, primarily because we wanted to keep that risk at bay. And the reason why we could do so was essentially Codefresh. Codefresh had done a very convincing proof of concept with Tigris, and they showed us that they can essentially reduce our maintenance burden to minimal, where these upgrades are reliable. They work in a controlled matrix. We primarily used ArgoCD, but the other software components that attach to ArgoCD were interesting for us as well. And we really liked that single pane of glass that it offered us as well, where we could just use our standard SSO provider, which happens to be Okta, and log into that same instance and get an overview on how all of our runtimes and instances are doing. So those were huge selling points for us, and Codefresh has made it very easy and simple for us to do so. And role-based access control was also another desire that we have for managing this platform, is to kind of decouple the complexities of managing the permissions as much as we can. And I think this platform is structurally sound to offer that. And I don't know if I'm allowed to comment on that on Codefresh's behalf, but I think Codefresh is also aware of that unique position they find themselves in with the single pane of glass. So I'm expecting good things to come out of it in the future. So what was the problem, again, at a high level? If you have a lot of ArgoCD instances that are remote instances running on-prem of a customer, with many different cloud providers that may require you to use a different set of ingress controllers that bring up those load balancers. And those load balancers can have also differences in behavior. And then on the other hand, you have the operational issues, the toil, if you will, with the security, the encryption, to make sure that your customer's data is secure, that you update the software regularly, maybe even monthly, like we do. Then the maintenance toil of managing IP allow lists and managing certificates for load balancers, and obviously managing the ingress controller software itself. Those seem to be the issues that we wanted to tackle and address. And one of the things that we came up with was, okay, how could we eliminate some of these issues? And one of the choices, once we decided that we will go with the many instances, was to use either the load balancers or this new feature that was called the tunneled architecture of Codefresh. which is essentially secure WebSockets or WebSocket security that it uses. So there are differences between these two solutions, and we'll drill a little bit into on what they are in a nutshell. So what are tunnels, and what is WebSocket security, WSS? Tunnels are just like in real life, essentially connecting two distinct regions, and then they help cross these boundaries between the regions. So they simplify crossing these boundaries. By encapsulating the packets, they also simplify data transfer in a way. They standardize the formatting of the data for you. So they usually pretty favored by security teams. In most of these cases, you will also encrypt the traffic on these tunnels, let them be any kinds of tunnels. IP security tunnels are probably the most well-known, but WebSocket security tunnels are, as you will see, not an exception to that. And they also help you multiplex and demultiplex connections. So instead of you having to define a large number of connections between a distinct set of endpoints, which can end up being an arbitrarily complex matrix of connections, you just have to build out this one tunnel, and just like cars would use a bridge to a tunnel, you would be able to multiplex or demultiplex these connections over the tunnel, essentially giving the security operations team a single path to look at and maintain. Probably one of the simplest tunnels that exist there are WebSocket security tunnels. What that gives you is essentially you can use the HTTPS port, in this case, the HTTPS port. So you're essentially creating a WebSocket connection over TLS. It should work with most setups. We found that a lot of environments were pretty forgiving and allowing for these types of connections. And it is a full duplex connectivity, meaning that unlike some IP allow lists that need to be handled bidirectionally, once this tunnel is established, the communication can happen bidirectionally. So you will have the client talk to the server, and the server can also respond to the client once the tunnel is established. So it's a bidirectional two-way communication that it provides. But why did we choose, even aside from that, tunnels? What was the Tigris specific lure, if you will, to use tunnels? Well, we looked at it and we said, well, if we go apply a lot of these instances, we have possibly thousands of customers in the future. How would this issue scale for us from both the maintenance perspective and also from the cost perspective? And we looked at our existing implementation at the time, and we found that it was at small scale not very expensive to maintain load balancers. Their cost in Amazon was roughly $25, give or take, and roughly $18 to monitor them with Datadog, with the on-demand plan, of course. Your mileage may vary. Versus tunnels were entirely free, and our existing network monitoring would cover it, so we didn't have to pay extra for a network host there on Datadog either. So obviously there was a financial impact there right off the bat. Now, from the security side of the house, we didn't have to maintain IP allow lists with tunnels. It seemed that because of how the infrastructure is, essentially the client is reaching out to the mothership that is Codefresh UI, it seemed to be that most setups were easier to maintain with that sort of a layout, where your server IP addresses may change. You can push these down to the clients, and you can orchestrate this distributed system very easily. Versus if you had individual customers maintaining the IP address lists and have to update their lists with their change management processes, it could get arbitrarily lengthy and complex. Also note that there is a different direction as these clients establish the connection first. So these need load balancers do need to be set up initially at Codefresh explicitly. The endpoints need to be configured, and then it makes the connection and establishes that. Versus on the tunnel side, you just basically specify, or you don't, in Codefresh's case, you don't even have to specify. It will automatically connect to the UI, and there is nearly zero configuration, obviously aside from that. And this is just the initialization, the direction of the traffic initialization. It's not the ultimate traffic like we discussed. That socket security is essentially a full duplex bidirectional communication. So this is just for establishing set traffic. So that would help us definitely with the maintenance of IP lists, and also would help us not to have to expose these endpoints on the internet. I'm going to jump back one more time to that previous slide. So these load balancers would obviously need to be exposed to the internet, and that is an attack surface for some who are concerned about who are very concerned about security, on the other side of security. And this process of using firewalls and just network address translations may make these backend instances untargetable from the outside without hijacking the traffic itself. So essentially, it is a better solution as far as we are concerned to not expose those backend services to the internet. And then it also comes with some nice side effects. So once you don't have a load balancer, well, you don't have to manage those certificates. I'm really curious about how many on the call are eager to manage certificates and how much it costs them, but we were hoping that we could avoid that issue altogether. So this was a nice benefit that we got out of using tunnels in this setup. Not to talk about the ingress controllers, which the support for them is limited to a set of ingress controllers. You might have to work with your custom ingress controller in some custom environments to bring up those load balancers. This last bit that we found was specific to Codefresh ArgoCD was that with the load balancer, we would need to annotate some resources after the installation of ArgoCD, and with the tunnel, we didn't need to do that. So it operationally, from the setup standpoint, we didn't need to patch these deployments and annotate them, these ingress resources and annotate them. We could just use it vanilla out of the box. So it was a nice little touch to the setup itself. And then we did run some assumptions. We didn't know what the feature was going to look like, but then a few estimates just to see what our benefits would be. Is it really worth doing it, or is it just like a smaller amount of money that will not be able to value that much, even at the, we would need very, very large scale to do that. So we did some assumptions saying that the infrastructure cost was roughly around $43. This includes the load balancer, the monitor, and the certificate management solution. Some platforms do offer certificates for free. Some platforms may not. And then we assumed a rough engineering cost of $67 an hour for any maintenance work that may need to be done on the whole infrastructure. This includes all the software that's involved and all the infrastructure as well. And we estimated that maybe an instance would cost us about 1 hour a month altogether, certificates, monitors management, reacting to incidents, those types of things. And this is what we found as a rough estimate. For 10 instances, our savings would be, and mind, we are a very small company, $1,100 a month with these numbers, where some part of it was infrastructure, but a lot of it was engineering. As you can see, the split favors the engineering in terms of cost. And then at 100 instances, it seemed like we would have significant benefits out of it already, where it is a non-negligible $11,000 a month that it would save us. So we thought that this would be a nice midterm saving for us, and we were hoping that we would get to a large number of customers in the future, where possibly 1,000 instances were not out of the question. And that would be a very, very significant amount of savings. I definitely would love to have that amount of money in my bank account on a monthly basis. So that seemed definitely worth the investment. And now I'll talk a little bit about provisioning our infrastructure with ArgoCD versus Terraform. Now we'll definitely leave some time in the end as well, for questions. I see there is a bit of an activity in the chat, so we'll circle back to those, and I'll answer all the questions I can. So what did we notice when we provision infrastructure here at Tigris? And this might be, some of it might be Tigris specific, or some of it might be Robert specific even, or I won't name on any other names on the team, but what we noticed was that there were some things that just worked for us, and it worked very naturally. And then some other processes were not as fun to operate for the team. And as you can tell from the slides, what ArgoCD and Codefresh brought to the table was fun to operate, and people wanted to do it. And we noticed that people were doing it. And we dove into the details a little bit on why that may be the case. What we noticed was that comparing the two infrastructures, we already had a very nice software stack deployed to manage ArgoCD and get CI/CD set up for our services. It seemed like second nature to the team to operate this. And because the state of things was in Git, and we used automatic synchronization with this platform, everyone kind of understood what the expected state and the running state was of the system. We had no problems with we had no confusions around where things might be, or what other things may happen when they made changes to the system. And therefore, no additional locking was required around Git changes. So everything just got natural with these workflows. The tooling really helped the team out. All of a sudden, we found our less infrastructure affiliated techs would also find it relatively easy to understand our configuration of DNS certs and load balancers. It was just an annotation, a side note almost to the team, and it was easy to ask our engineers to make some changes. Now, on the other hand, Terraform did require us to deploy some supporting infrastructure, which I guess it's natural, expected. We chose Atlantis for that and it was required to manage the locking around the pull requests. And what were the challenges with it exactly mirrors the benefits of the other platform, that the state was stored outside of Git. So we had to occasionally tackle some race conditions, some side effects, and that left us with a bit of a reluctance in managing these upgrades with Terraform. So people would not want to do upgrades as easily as much. Definitely not on a monthly basis. And there were some problems with conditions like targeting specific resources was necessary to bring up more complex deployments. And sometimes approved plans could go stale, or you would have to make sure that your PR branch is absolutely rebased before you actually plan and apply. So those types of issues led to us thinking, why can't we leverage the ArgoCD platform more? So we just can look at infrastructure as if it was just another app, same interface that works for our engineers will be useful for them. And these were the low-hanging fruit for
Robert,
us.
just wanted to add something on the previous slide. So you would remember initially when we started, we did use Terraform more heavily, right? And we did start to use ArgoCD at that time, but we were using ArgoCD just for the applications. But for most of the infrastructure, we were still using Terraform. And we came up with this idea of what is dynamic infrastructure and what is static infrastructure. And that was a principle we chose to decide which tool we are going to use. So for the static infrastructure, for all of the reasons that you mentioned here, we decided to stick with with Terraform, but anything that required dynamicity, that's where we could get the benefits of ArgoCD. So it's not just that we think ArgoCD makes sense just for your microservices, but it also made sense for a lot of the infrastructure components that we have deployed using ArgoCD. So that might be a good distinction when someone is comparing when to use Terraform and to use ArgoCD, that if you have a dynamic, if there are pieces of your infrastructure that are dynamic, that are going to change more often, then it's better to use a system that's built for this dynamicity, which is ArgoCD, and use Terraform for setting up the base infrastructure. For example, in our case, when we set up the Kubernetes cluster, that's where we use Terraform. We don't use Terraform beyond that.
Exactly. Thanks for that note. Exactly right. So it definitely is more of a Kickstarter for us in some of those cases where we have to deal with the nuances of the infrastructure, and then some of the software that we looked at, the infrastructure related software or the infrastructure related resources that we looked at, I think became also a little bit more dynamic for us. Like we don't really change the load balancers that much, but it's very easy, to change an attribute on set load balancers through a annotation versus going to find the specific resources. So it seemed like it had also a lower barrier for engineers to adapt this new system. It felt a little bit more abstract, even more abstract than Terraform did. But yeah, there is still bits and bits of pieces that Terraform manages for us, and by reducing those to the minimum, it still allowed us to leverage Terraform for what it's really good at, and that's versatility at for multitude of different platforms. But it also allowed us to be a little bit more quicker, agile on reacting to pieces of software that could be managed with ArgoCD. And
yeah, and we make, and just to add, we have several deployments every week. So I would say that we release several releases that we do every week. So dynamicity was important for us. And the other point was also we found out that the tooling that ArgoCD provides, it's much more user-friendly as compared to Terraform, and moving more workload to ArgoCD also enabled us for more engineers who are working on the product side, not necessarily on the platform side, to take more active part with some of the infrastructure management as well.
Absolutely, it's a great point as well. We experiment and we add new components to the system that is our data platform, and that was made super easy with ArgoCD, adding certain components, scaling that to the workload. When we learned the initial system on how that behaves with actual production users on them, we could react to it very easily, and it was very nice for both the development aspect of things, where you could switch to development branches, certain apps, kind of twisting the GitOps principle a little bit there, and experiment with that, as well as from the production reliability side, scale and adapt very easily using generic tools that everyone on the team will understand. That is a great point, Ovais. Thank you for raising that. So some of the low-hanging fruit that we found from an infrastructure standpoint were components that we do traditionally configure from within Terraform, and we found that updating these, obviously while making sure we understand the changes that will go into that platform, but making the actual update relatively easy for us was for these components. So with this, we could roll out a recurring operational cadence where we would just upgrade these components as well as some others. And there's been some discussion, some crazy thoughts about what else we could do. There's virtualized Kubernetes clusters out there these days where you could come up with some custom environments on the fly, and all of this can be made very easily with soft platform like ArgoCD/Codefresh. So yeah, so basically some of the best practices that we found were in order to leverage this platform at its highest peak, was to use a modular design as much as we could. That these resources that we manage, there are no two managers, two authoritative sources updating the same. So we would be ensuring that these islands of management are well designed. They are managed and operated by a single authority. There's no two things updating, two managers updating the same resource, and that we limited the privileges to managing only that specific scope. So that helped with both security as well as avoiding issues that are accidental, say one environment updating another environment's resources. These would be the controls, and we had multiple breakpoints in the system for this. We limited the network access, we limited permissions across these boundaries so that accidents may not happen. Like one of my favorite quotes from early Ghostbusters was, "Don't cross the streams we believed in," and we exhibited that with the cluster. And then, last but not least, we kind of wanted to oversee these deployments, understand how we are doing from both the agility standpoint as well as understand what faults we may have in the systems. And specifically, Codefresh was something that avoided having to build our own overview for these systems. With lots of ArgoCD instances, you'd either have to build these systems, build this view yourself along with the authentication that goes with it, or in our case, we found a great partner in Codefresh for doing that. As you can see, there are different applications here. Namely, we have 113 healthy and 4 progressing in the specific view, and we can get notifications at a single pane of glass, can easily find holistic problems that may happen in our systems if, for some reason we made a problem, introduced a problem with one of our deployments. So that was enormous for us to be able to control that. Along with, by the way, DORA metrics as well that give you data on the velocity of your deployments and any failures and recovery times. If you want to operate that and turn that into KPIs for your team, this is the way to go. And then we got that overview here as well on the GitOps dashboard. I could even pick a specific runtime, right, like our preview, and see how many, what applications have been active, what kind of needs focus from our team's perspective in terms of deployments. Where is the most active deployment? Have we, made it easy for people to do these deployments? What are the possible challenges? And sometimes it also helped gauge possible earlier go lives. In a way, these metrics helped us understand where things are trending from the team perspective. And other issues with the deployments and rollbacks, the DORA will get you that as well. And then it also, having these holistic instances also allowed us to do monitor things at a very high level. One metric that we found was particularly useful was ArgoCD app info. And the two aspects of that metric were health status and sync status that we found useful. And in these cases, health status, and if you don't remember what these are the application statuses for ArgoCD. So if you have an ArgoCD service/application, it will have two aspects of things. Once it synchronizes and once it establishes a certain health state. The health status is usually healthy or progressing when you do deployment. So those I would call the healthy states that you don't need to alert on, or we don't alert on those things. Progressing is a transient state. So if you were to alert on that, it will get very noisy. And similarly, when the application is trying to rectify the differences between a desired state and the running state, there are healthy states such as synchronized or sync and out of sync. Out of sync is a healthy state if it's not stuck for a long time. You may need to have another alert for that. but it is actually also normal, the regular operational aspect of applications. So you will not want to monitor on those. Whereas in health status, having an application in a degraded state, unknown or missing state will most likely mean that you have an issue with your deployment. Same with the synchronization status unknown, where the Git branch perhaps has gone away. Something isn't set up right, so we alert on those, and we do also alert on the suspended state in health status in case someone forgets things there. So we will always want to be close to the GitOps principle and have the Git repositories maintain and reflect the state we are in at. If you are very curious about how these states are being defined or where they are, I included a few links from the source code where these states are described and defined. So feel free to use that, or at a very high level, you can also peruse the operational manual to see what these states mean for ArgoCD. But having these metrics be available globally allowed us to simplify our monitoring and allowed us to deploy monitors that in a unified way, further decoupling the concerns. And this screen shows some issues with health status and sync status for two specific occasions in our environment. But what's more important here is that you may notice that these metrics are also namescape. So depending on how you put these metrics in the same or the different namespace, you can control them and group them. For example, if your metrics are all in the same namespace, say CF Codefresh or CF ArgoCD, then with one single monitor, you can essentially monitor all of your environments and have a catch-all. Versus if you want to separate them, like if it was, there was a logical separation for our case, you can put them into a logical bin like preview was for us, even though it may or may not contain multiple runtimes. For example, production would be a probably better example there. And you can apply that, apply the settings to the specific environments that way. So you can namespace these entries and you can group them, and you don't have to have 1,000 monitors for 1,000 instances if you don't feel like that's going to benefit you as well. All right.
Robert, just one more thing to add to the previous section. You touched about the central pane of glass. So I just want to talk about it from product perspective, that these days it's very crucial for users to be in control of the data. And when we were building Tigris, that was one of our primary goals, is ensure that we are able to support deployments within the customer's account. And this is not something that we are this is not something that we are the only one doing. Any stateful platform, it's a best practice for the data to be for the user to be in control of the data. And that's where the single pane of glass becomes extremely important, where having this visibility into each of the deployments, being able to control it in a secure way, as Robert mentioned, is absolutely important. And that's one of the biggest benefits of using Codefresh.
Thank you, Ovais. That's a really, really good point as well. I'm glad you raised that. Yeah, having also the ability to oversee and control the flow of data is huge. So that's partially why people like data platforms, and that's definitely why we also chose Codefresh. We would definitely have to build this system if we didn't get that. But fortunately, it was available for purchase. Any other thoughts before we jump into the final thoughts, Ovais?
No.
Okay. So as a final thoughts, I would say that infrastructure can definitely, I hope we showed you an example that infrastructure can be a partner for agile software development, where you add, remove components separately and scale them, as well as production support. It is a huge benefit to be able to do that on the fly and embrace the cloud mindset. And what we found was it is just so much easier and better to use Codefresh to do help us manage these large scale deployments instead of writing our own. They've been a great partner for us. I can talk from both the architecture and support perspective. And furthermore, when we have a lot of these instances, it's very nice to have tunnels for that. That simplifies the deployment scenarios further. And with all of that said, if we can standardize most of the components on ArgoCD with GitOps for infrastructure deployments, as many of we can, a lot of engineers feel engaged and will manage the platform for the company, which was crucial for us given the size of Tigris data. And yeah, that's what we think. Let us know what you think.
Just to add to the first point, I think that over the years, that's where I have seen where there's a struggle between infrastructure engineers and app developers, where app builders, product developers, they want to be able to release as fast as possible, and whether it is releasing within staging to test out their changes or releasing new features and fixes in production. Infrastructure, as you have rightly mentioned, is a partner there. So when you're designing infrastructure, it's absolutely important to have that thing in mind, that is my infrastructure going to be able to enable fast releases? Is it dynamic? And I think that based on our experiences, if you choose to have this infrastructure deployment system built using ArgoCD, then that will help your infrastructure to be agile. And of course, that will remove one of the major roadblocks that engineers have in terms of being able to do more frequent releases.
Yeah, and self-enablement really is helpful to enable those engineers to do deployments on their own, and they feel empowered by the tooling that we deploy to them, rather than have someone be involved and oversee the process for them. Where perhaps the process that exists may not feel as robust. So it takes that modular system, good tooling, and the lovely platforms that we get these days from the cloud providers, like Kubernetes and obviously Codefresh. All right, with that said, if there are any other questions, we'd love to take them. Let me stop my sharing really quick and see if I can take a look at the questions in the chat. Question and answers. Interested in ArgoCD versus Terraform in examples, do and don'ts. If ArgoCD, then why? It's a great question. So from a do and don'ts, if there are tools to manage that resource, and you can separate those resources into distinct management realms, then I would say do. If there is easy, great support, it's maybe a one-off for you, I would go with Terraform. For example, there are in the industry interesting directions. One of which I used to be a big fan of and still am, is the definition of monitors along with resources. I'd love to see more of that being defined in YAMLs and be deployed along with the applications, just like a first-class citizen. But a lot of vendors, a lot of providers find it easier to write that in Terraform, and even Datadog has had support for that in the age, and they kind of backtracked it and deprecated the custom resources there. I would say that not just for the deployment aspect of resources, but also from the operational aspects of things, where you have to package some knowledge, some how-tos with your product. If it's a little bit more of a stateful or complex workload, and you want to package some operational goodies, operational knowledge along with that product, I would definitely do that with operators and Kubernetes, because like we said, it's a denominator for infrastructure at certain level, and it helps to manage that in an abstracted way. There are some resources that are not readily available. There are some cloud providers that are experimenting with managing more of the infrastructure with ArgoCD. For example, virtualized Kubernetes clusters with KubeVirt and the related clusters and resources. Sivu, I think, has been pretty vocal about managing more of their virtual infrastructure with operators. I'm really looking forward to hearing more and reading more about that landscape to see, where that takes us, and we can further decouple the kickstarting from the dynamic management of resources there.
From a base infrastructure perspective, so if we just look at our example, then the VPC setup and the cluster setup, that is handled through Terraform, and then everything else is done through ArgoCD. Would that be a good way to define it?
I think so. Thanks, Ovais. Yep, I agree. I think there is another question here. What entities are you synchronizing with ArgoCD application sets in an EKS cluster, or do you use it for other types of infra resources too? So we do use annotations and controllers to manage certificates, DNS resources, load balancers, primarily those types of things. There are some data specific resources as well, some custom resources that we manage. But we do have, at the application level, we do have applications, and apps of apps seems to be where we got the most benefits. I'd love to see some apps of apps features make it to application sets, if you know what I'm talking about. And primarily because what we are doing is we are packaging a complex application suite in Kubernetes. So it's not the usual single component that you package, but with some additional components along with that. That means you would bring these applications up in a specific sequence. For example, you would want to ensure that Foundation DB, which is our key value store we use, is available, readily available before we start our database, or our certificates are ready before we bring up another component that does handle specific types of web requests for us. So orchestrating these, ArgoCD is a really, really nice platform to do that. And I find that we are stepping a little bit beyond containerization, where we are talking about these application sets and we are packaging them now and trying to deliver that to customers. That's where it can help. Hope that answers your question. If not,
I think that was perfect, Robert. Yeah, and Matthew's saying great answer. Thanks for the additional details. So I think we are at the top of the hour, so we're going to come to a close. I did promise some codes, so we're going to put those up in a second, but I want to give a huge thank you to Robert and Ovais. That was fantastic. I think you guys did a great job and illustrated a pattern that people can really follow. Well, let's show. So if you want to be like Ovais and Robert, if you want to be pros, definitely check out the GitOps certification. We have a free code, I Heart GitOps. This expires tonight, so go set it up. Learning.codefresh.io. We'll throw the link in the chat. Ovais and Robert, any social media or channels you want to plug, or things that Tigriss is doing that you want to mention?
Yeah, I mean, all the information is on the website. I'll just type it here on the chat, and yeah, please do visit our website, and we continuously keep it updated with latest updates on our side.
All right, perfect. And then to everybody who joined today, just huge thank you. And if you haven't done it yet, make sure to register for our next upcoming webinar, all about CI/CD for Kubernetes apps. We're actually going to go a little bit more hands-on with some of the stuff that you even saw today. And I'll actually be back to talk all about how microservices should change your CI/CD strategy. how you can use Codefresh to build, test, and deploy our applications in a smooth end-to-end GitOps-enabled flow. And you'll leave that webinar with a clear idea on how to save money, reduce downtime, improve your time to recover from failure, and of course, be the DevOps hero your team needs. So we're going to throw that link in the chat. Make sure to register, and we'll see you there. Thank you, Ovais. Thank you, Robert. And thanks, everybody, for joining. Fantastic content and guidance. And we'll see you at the next one.
Thank you for having us here. Yeah.